Now, since we know the shadow is moving in simple harmonic motion, we can use stuff that we know about circular motion to figure out some facts about the period. Now, starting out from this point, velocity of the shadow is equal to velocity of the pin, or v naught, the maximum speed, times the square root of 1 minus x squared over a squared, where a squared is the radius here, but was the amplitude for the spring mass system. Starting from this equation, now let's start to look at circular motion. This thing is moving around and it's got some angular speed, omega. Here's what we know about omega. First of all, we know what omega is defined as. Omega is theta over t, delta theta over delta t. That's what omega really is. Here's another thing we know. We know that r times omega in general is equal to velocity. Applying that to here, that means velocity of the pin, or velocity naught, is equal to a, because that's our radius, times omega. But omega is delta theta over delta t, so that means the velocity of the pin, or the maximum velocity here, or the shadow, is equal to a times delta theta over delta t. What we're really trying to find here is the period, and the period is the time that it takes to do one revolution. So in one revolution, delta theta is 2 pi, so let's plug that in here. Velocity of the pin is a times 2 pi over, well, the time for one revolution is the period, capital T, which is what we're trying to find. So we'll solve for t. The period then is equal to a times 2 pi divided by the velocity of the pin. But remember, the velocity of the pin was the maximum velocity for the shadow, so we could also write a times 2 pi over v naught, maximum speed, is the period. Thinking back to the spring mass system that we were originally concerned with, we know that v naught was equal to a times the square root of k over m. So let's substitute. Period is then equal to a times 2 pi divided by v naught, which is a times square root k over m. Let's simplify. A cancels out. That leaves us with 2 pi on top times the square root of the reciprocal of k over m. So m over k. That's the period. So for that spring mass system, 2 pi times this constant that depends on the mass and the spring constant is the period for that system. Notice what it doesn't depend on. It does not depend on amplitude. That doesn't matter. How far you stretch it a long way, stretch it a little way, the period is going to be the same. The time it takes to go from one extreme to the other and back again doesn't depend on where you start. Big stretch, little stretch, medium stretch, doesn't matter. The period will be the same.